Hello everyone, my name is Shashank and I'm from Sri Venkateshwara College of Engineering. Today we are going to learn about relational algebra operations in DBMS. Introduction. What is a DBMS? DBMS is a database management system. It is a software system used to store, retrieve, and run queries on data. A DBMS serves as an interface between an end user and a database, allowing user to create, read, update, and delete data in a database. Data. In the context of a DBMS, data refers to facts, figures, and other relevant information that can be stored and proceed. Database. A database is a structured collection of data that is organized and stored in a way that facilitates efficient retrieval and management. Databases can range from simple single user system to complex multi-user systems used by large organizations. Relational algebra is a formal system used to manipulate and query relational database. It provides a set of operations that can be applied to relations tables to retrieve, filter, and combine data. Types of relational algebra operations. Some of fundamental relational algebra operations are selection, projection, union, intersection, difference, Cartesian product, join, division. Let's start with selection operation. The selection operation is a relational algebra. It's used to filter rows from a relation. Based on a specified condition or predicate, its primary purpose is to retrieve a subset of data that meets specific criteria. In mathematical notation, the selection operation is represented by the Greek letter sigma. The selection operation allows you to choose a subset of rows from a relational that satisfy a given condition. Syntax. Sigma condition of relation. Sigma, the symbol denoting the selection operation. Condition, the logical condition and predicate used to filter rows. Relation, the input relation or table from which rows are selected based on the given condition. Example. Consider a relation between students with attributes columns like name, age, grade. If we want to select only those students whose age is greater than 21, the selection operation would be expressed as sigma of age is greater than 21 of students. This operation would return a new relation containing only the rows where the age is greater than 21. The above picture shows the total students column, name, age, and grade. The below picture shows the result of the selection operation. Projection operation. The projection operation in relational algebra is used to select specific columns from a relation while discarding the others. It allows you to create a new relation that includes only the chosen attributes, providing a way to focus on specific aspects of the data. Syntax. Pi attribute 1, attribute 2, and so on of relation. Pi, the symbol denoting the projection operation. Attribute 1, attribute 2, and so on. The list of attributes to be included in the resulting relation. The input relation or table from which attributes are selected. Example. Consider a relation students with attributes like name, age, and grade. If you want to create a new relation containing only the name and grade attributes, the projection operation would be expressed as pi of name grade of student. This operation would result in a new relation with only the selected attributes. Name. This picture shows the name and grade output of the projection operation. Union and intersection. Union operation. The union operation combines the rows from two relations to create a new relation that contains all unique rows from both relations. Syntax R union of S. Interaction intersection operation. The intersection operation produces a new relation containing only the rows that appear in both input relations. Syntax R intersection S. R and S are the two input. Example: consider two relations, students and instructor, with each attributes like Fn and Ln, where Fn is the first name and Ln is the last name. The union of these relations denoted students union instructor would include all unique rows from both relations. This table indicates the students and this table indicates the instructor. This is the resultant of instructor union student. Using the same students and instructor relations, the intersection of these relations denoted students intersection instructor would include only the rows that exist in both relations. This table indicates the resultant of the instructor intersection student. Difference. The difference operation in relational algebra is used to retrieve a new relation that contains all the rows from the first relation that are not present in the second relation. It is sometimes denoted by symbol minus. Syntax R minus S. R and S are the two input relations. Example: consider two relations, student and instructor, with attributes columns like and Fn. From the previous student and instructor, we are taking student minus instructor. This table is the resultant of the student minus instructor, and this table indicates the instructor minus student. Cartesian product. The Cartesian product operation in relational algebra combines every tuple from one relation with every tuple from another relation, resulting in a new relation. It is denoted by the symbol into. Syntax R into S. RS are the two input relations. Example: let us consider two relations, employees and projects, and find the Cartesian product of these relations. These relations. This table indicates what are the employees like employee ID and employee name. This table indicates projects like project ID and project name. This is the Cartesian product result: employee ID, employee name, project ID, and project name. Join. The join operation in relational algebra combines tuples from two relations based on a common attribute, creating a new relation with combined information. Join is a fundamental operation for retrieving related data from multiple tables in a relational database. Syntax R join S. R and S, the two input relation, into this symbol denoting the join operation. Condition. The join condition specifying how tuples from R and S should be matched. Example: consider two relations, employees and departments, with attributes like employee ID, employee name, and department ID, department name. This table shows employees, employee ID, employee name, and department ID. Departments, department ID, and department name. Inner join result. Joint results are employee ID, employee name, department ID, and department name. This is the resultant table of the join. Division. The division operation in relational algebra is used to find tuples that, when combined with each tuple from one relation, result in a match for all tuples in another relation. It is denoted by the symbol division or bar. Syntax R divided by S. R and S are the two input relations. Let us consider an example with two relations, employees and projects, with attributes such as employee ID, project ID, and role. Projects divide employee ID, employee name. This table shows the employees, this table shows the projects, and this is the resultant of the division. Conclusion. Relational algebra operations include in selection, projection, union, intersection, difference, Cartesian product, join, and division are fundamental for working with relational database. These operations provide a set of powerful tools for filtering, combining, and extracting data from relational tables. Integral to constructing requires in languages like SQL, relational algebra ensures a formal and mathematical foundation for relational database management. The operations enable users to express complex relationships, retrieve specific information, and maintain data integrity within a relational database system. A solid understanding of relational algebra is essential for effective database design to proficient data retrieval in database management and development. Thank you.